Hello, this is part 2 of the absolute value inequalities video set. So here we're going to try the absolute value of the quantity 7x minus 8 is less than or equal to 6. We're going to find the solution set. This means the distance between 7x minus 8 and 0 is less than or equal to 6. Okay, so seeing here, this less than or equal to 6, that will go with this statement right here. Now, 7x minus 8 comes from what is between the absolute value bars. Okay, now thinking back to what our example was in part 1, I thought of the balance beam idea, right? You're standing on a balance beam and you have to be, right, you can't go 6.1 feet, right, because you'll fall off, right? So this 6 feet, kind of imagine as the end of the balance beam. Okay, so in part 1, I talked about that analogy. So I know that I'm going to be between, right, -6 and +6. You could think of that. So really, what I'm starting out with is I'll mark 0 here, and I'll mark 6 and -6, and 7x minus 8 I will place here, right? I could imagine that as going either to the right or to the left. And I know that I would shade in the in-between, right? Because that's where I'm walking on the balance beam. It has to be less than or equal to 6. Okay, so now I need to put this all together. Remember, this is the AND statement, right? Putting everything together here. So what I'm going to do is take 7x minus 8 less than or equal to 6. That would come from this right-hand side part. And if I go to the left-hand side, this would be 7x minus 8 and -6. Well, I could see that I'm pointing to the right, so this would be greater or equal to -6. Also notice, if we have greater or equal to -6, less than or equal to 6, you can compare those two. If you ever multiply or divide by a negative, you flip the inequality symbol. So by introducing the -6, just remember to flip the inequality, right? We had +6 over here on the right. We just kept it less than or equal to 6. But when I introduced that -6, I flipped the inequality. That's how I remember it. So we need to solve both of these. So let's see. 7x minus 8 greater or equal to -6. And we have 7x minus 8 less than or equal to 6. Well, with both of these, if I add 8 to the right-hand side, add 8, well then I make this a little bit simpler for us. So I'm just treating it just like there's an equal to there and just solving the equation. So now I'll have 7x is greater or equal to 8 plus -6. Putting that together, you should have a +2. If I go on the right-hand side now, when I add 8, okay, 7x less than or equal to, now 8 and +6 added together would give you 14. Now, with both of these, you have 7x multiplied by an x. So I can divide both sides by 7, and you would have x greater or equal to 2/7. And then this one would be x less than or equal to 2. And we need to put this together. Okay, so I'm going to make two little number lines here. Okay, I'm going to mark where 0 is. Let's mark 2/7. It's equal to, so I'm going to mark a filled in circle, and then I'm going to shade to the right because the greater than or equal to. And then here I'm going to mark 0 and +2. Okay, 2 is equal to, but it's less than or equal to 2, so I'm going to shade to the left now because of the less than or equal to 2. And then what I need to do is put these together, because remember this AND statement. It's this and this. So let's make one single number line and label 2/7 and 2. Both of them were equal. And we could see that with the shading, that if I mark 2 here and I mark 2/7 there, really you could see that the overlap in shading would be in the in-between. Now, we know it would be on the in-between because if you think back to the beginning, think back to here, we know that we've shaded in between, right? Think of the balance beam idea, right? You can walk anywhere on the balance beam between ends of the balance beam. So then what I can do here is write my interval notation that we have 2/7. I'll put a bracket to +2. This would be my solution in interval notation. 2/7 to 2 would be my solution. Okay. We could check, if we'd like, we could check any value, right? Let's see, it looks like a 1 would land in between there. So if I take the absolute value, and we had 7x minus 8 less than or equal to 6. If I take x equals 1, let's just check that. 7 times 1 minus 8, is that less than or equal to 6? Well, so 7 times 1 would give you 7. We have the absolute value of now 7 minus 8. That would be -1. But the absolute value of -1 would give us a non-negative, which would be a +1. Now, is +1 less than or equal to 6? Yes, that sure is. So having x equal 1 in our solution set does make sense. That is valid, right? Now, really, I only checked one solution there because if you think about it, there's infinitely many solutions in between here, right? Like 1.01 and 1.9 and 1.7, right? You could think of so many possibilities, right? Infinitely many that would work. Now that is one way to do this with the and statement. Another way, which I mentioned in part 1, is you could have wrote this as -6 less than or equal to +6, right? And then in between here, let's put 7x minus 8. So we have a compound inequality here. And what you could do is just solve this as is. Treat it like there's equals on both sides. And what I'm going to do is add 8 everywhere, right? The left-hand side and the right-hand side and that middle. When you add 8 to everything, well then you could see over here you get 2. Then you have less than or equal to 7x, less than or equal to 14. And you see how it mimics what we've did by splitting them up separately. And then here, I could divide everything by 7, divide everything by 7, and you get 2/7 less than or equal to x, less than or equal to 2. Now, doesn't this exactly represent our shading here? Well, it sure does. And in interval notation, you have it also written here. So it definitely matches up. It definitely works out very nicely. Okay, thank you for watching this video. Watch part 3 for another example